Hey guys, welcome back to the next video. In this video, we are going to talk about the network architecture. Now, in the next video, we'll be actually configuring network and try to browse the admin console. But before we do that, I just want to tell you about this architecture. Now, this may seems to be a bit hard or off topic for people who is directly coming from, WebLogic without having much experience on networking or Kubernetes. But I'm here to make sure that this journey is much simpler and easier for you to get through. So, what I'm going to tell you is that you have these many networks over here, which we're going to work across. The first one is the laptop one. So, the one which is currently in my laptop is the World Wide Web, as in it's connected to internet. So I cannot access any of this server with any other IP rather than the NATed IP through the Amazon Web Services. Now, the Amazon Web Services has given me IP address, which is a NATed IP address. Now, if you see on the Ubuntu server, the actual IP address which it was hosted with is this one. So this is the actual IP address and internal IP address. So that's what I'm representing over here. So this is your Ubuntu network. That's basically the IP address on the Linux system. But then through NATing, AWS has given me a public IP address, which I'll be actually using to browse any of the stuff which goes on within the server. The next one is the Kubernetes network. So the Kubernetes comes with its own network. And that's something which we have installed. If you remember, we have configured that specific item, and we are using that to connect with Kubernetes internal pods. And then for WebLogic operator, we have installed a specific service called Traffic. Now, Traffic is a specific proxy service which we have installed it as part of, our servers. So every Kubernetes instance has this particular Traffic proxy. Now, using this traffic proxy, you will be actually creating a service for traffic proxy. So this is the traffic service, which has exposed the node port number as well. What's the use of node port number? Node port number is how I can access the service through the public IP address, because the node port number establishes this particular node to have the port number exposed on the service, and using that port number or port number of the node port, I'll be able to access it from my public IP address, because everything will be forwarded, which is hosted on this network. Everything will be forwarded to the public IP address. So Traffic enables me to browse the stuff which is going on this level, right? Now, that's one thing. Okay, that's a very important thing, and we will see that. And the next thing is the service, right? The service is like a mediator between the Kubernetes network and the Ingress network. So Ingress cannot connect directly to your pods. Ingress is a network adapter. It's just like a network load balancer, but it is not type 4 load balancer. It is layer 4 load balancer. It's not a layer 4 load balancer. It can work as a layer 4 load balancer as well, but then it has like much higher purpose. Like it is a layer 7 load balancer. So I'll tell you about the Ingress, but then it's always recommended to take a full training on Kubernetes to understand it much deeper, and I have a course on that, which explains you about Ingress and the other properties. So in that example also I've told you some way, but it's also covered as part of this training. So I'm going to tell you about that as well. So don't worry about it. Awesome. So the service here is actually talks to your pods. Now this service of admin service and cluster service is going to be set up by when you have created. So now you have created these pods, right? These pods actually has kickstarted some service. Now when you do kube control get service -a, it's going to show you across all namespace. So ignore these two namespace. The one which you're concerned is this one, the traffic. So this came after we installed the traffic Helm, traffic operator. After that, we got this one. This is going to be the one, okay, to where we will be browsing through node port number. This is the one. So this, without this, you couldn't browse any of this, okay? So do remember that. So here, this is the node port number. So if you're browsing with this IP address, you combine with this one. If you're browsing with the external IP address, you will combine with this one because this is a node port number. So they have opened it for both HTTP and as well as HTTPS. So if you're planning to browse WebLogic console on HTTPS, this should be the port number. I'll show you that as well. Okay. So as part of creating these pods has eventually created these services. Now, this is not something which you have created by yourself, but this was created by the configuration within which was within this pods. Okay, so this is a WebLogic oriented configuration. Nothing has to be done from your end. What are these? These are basically services which goes and assigns to a pod. Okay. For example, how do we understand the relevance between this and this, right? That should be the question. How do we know that they are related, right? So just do a description, control describe service name -n namespace, give the namespace name. Now here is the important thing, selector. Now this particular service will be selected upon what is mentioned over here as a selector. Now we see this, there is a specific criteria here for this particular service to be applied upon. Okay, so the criteria is divided into 3 in this scenario. Because how am I saying it's 3? It's because there's a comma, right? So I see 2 commas, so that must be 3 arguments there. Now, instead of F&O wide, right, I will use one more option called show labels. Now, using the show labels option, using the show labels option, I can actually see the labels which is assigned to this particular pod for every pod which is there. I think this is enough for us to, showcase this. So here, the selector is for this particular service as pro tele domain admin server. This is the selector configuration. We'll come to the port. Okay, I'll come there. So here you see that WebLogic created by operator is true. WebLogic domain is pro-tele domain. And WebLogic server name should be admin-server. Now, if you see the 3 pods, right? So if you see that's created by operator true, yeah. So this matches. And then domain name is pro-tele domain, it matches again. And then the server name is matching also, admin server. So this particular item is targeting this particular pod. Now, is it targeting this pod? Now, if you see that, well, domain ID is the same. So you can see that domain ID is pro-tele domain. You can see that the operator, created by operator is true as well. But here the server name here says manage server 1. So this particular item does not belong to this. Okay. So this pod will belong to this. And you know that WebLogic by default hosts on 7001. And in this scenario also, in the document you saw in the YAML file that WebLogic was chosen to run on 7001. Okay. I mean the admin console, right? So here are the 2 port numbers which is defined. One is the port number of the service. So you should always remember the service itself will have a port number. It has to have a port number. And what it is targeting, what its target port number, what it is looking out for is 7001 as well. So that's the target port number. Endpoint port number can be different. It could be pointed to the current IP address of the system. And as this is a describe means it is explaining an existing service. So it just shows you what actually is currently running. So that's why it is giving you the IP address. And we will never give IP address anywhere to hardcode because IP address keeps on changing here. All right. Now, when you look at the same service, like for example, let's describe one more service over here, which is your cluster one, which has IP address. There's a reason why it has IP address. I'll come to that. Um, when you look at this one, right? So now here, the selector is different. So you still have the two selector is created by operator is true, and domain ID is prod daily domain. So that's something which is already there, which you've seen. But here, there's one small difference here. So it says like WebLogic cluster name is cluster one. So whichever managed server which comes under this cluster one name is going to be there. So here, there's one modification over here. So this instead of cluster, right, it should be server one. So just that one change I forgot to modify. It's 2, 3, 4, 5. So now if you see this server, right, managed server one, see that? So here it says server name is managed server one, and then there should be a cluster name somewhere here. Cluster name, cluster name, cluster name. Here you go. Cluster name, it says cluster one. So that goes back over here in the selector, and this basically selects it because it is part of the cluster one. And as you know that you have two servers running, as I told you, right? So there will be two JVMs running because it says like that. Okay, replica is 2. So you can see that you have 2 endpoints here. And 2 endpoints points to 10.44.0.2 and 10.47.0.4. So these two servers. So you have worker 1 and worker 2. I've not actually given the host name of it. That's why you get the IP address of it. But this is worker 1 and worker 2. Okay, so this is control plane, compute plane 1, right? So this is like what, 149. 149, this is worker 1, which is compute plane 1. This is compute plane 2. You can actually change the host name and restart the servers. And you will actually get the host names here rather than the IP addresses. So it's not a big deal. So what it is trying to do is like every managed server gets created across different pods. So if I have to put this across, right? So this is hosted on, I'll remove dynamic cluster. I'll put this is running on so one is running on like compute plane 2, and this is running on compute plane 1. So when you increase the replica numbers to 3 or 4, then it starts repeating again. So another one goes to compute plane 1, another one goes to compute plane 2. Likewise, each managed server spins up in different server. So the domain of your my application is going to be versatile, and it's going to have horizontal clustering here. So you're going to have like 2 nodes here where your servers are going to be hosted on either one node, and it's going to keep on coming up. And the best way to see that is by describing this cluster configuration, because the cluster configuration should compress of all the servers which is running, isn't it? So that's what you see over here. The good thing about this is like every pod will have its own IP address. So 8001 shouldn't be an issue because every pod will have its own IP address, though it is hosted on different on the same server. For example, this is next server will be on let's just say on compute plane 1, and then the other server is on compute plane 2. In this scenario as well, each pod is going to have its own IP address. So every pod, you may see this IP address or your host name gets repeated, but it's going to spin up with a different IP address. So 8001 is going to be possible because it has unique IP address assigned to it. And once you have the replication of 5 is a maximum number of clusters, right? Then what you will see over here is basically 5 different endpoints. And when someone accesses this IP address and this port number, they will end up in any of this servers. So that's what we're going to look at. The application which we have deployed, right? The test application which was done by Oracle. Now that when you refresh it, it will say which managed server it's coming from. So you can understand that how many managed servers are involved and how the application is getting refreshed. By default, session persistence is disabled. So you will see that it is not going to be persistent. So every time you do a control refresh, you're going to see like which server it is coming from. Awesome. So so far so good, isn't it? So We have not done any configuration so far, so we just like going through the theory stuff of about it, what's going to happen or what would happen. And one of the important thing is Ingress. Ingress is going to change the way you look at it because it's a type 7, it's a layer 7 load balancer. So I'm going to explain you now how it's going to work. Now, how you're going to access this is two different ways. But here, the only way to access any of these services using traffic, but traffic is listening on one specific IP address, and you have multiple services over here. One is for the admin service, one is for the cluster service. Though you have managed server 1, managed server 2, which is individually configured for the individual servers, but we won't be using that because it's all coming under the cluster, right? Cluster 1. And all these services individually, there's no point of browsing it individually as a service. Though you can actually load it from this IP address to access that individually. But when you talk about like accessing the cluster, it's always good to go with this cluster. But how are we going to use one single IP address? One single port number, and how are you going to browse two different services? And two different services goes to 3 different ports, and it may go to 5 different ports as well. That's the question, right? Now, firstly, we divide it into 2, right? One is admin server request, and another one is cluster request. Because cluster goes to 5 servers eventually, if you have the 5 replicas for like cluster members when you enable it. But as of now, it's 2. So let's divide this. There are 2 things. So I want to use this one single port number for HTTP, and I want that to get redirected either to admin server or to cluster based on a specific scenario. That's where Ingress comes in. Ingress is a layer 7. I've been saying that many times now. What is layer 7? Layer 7 enables not just routing between HTTP and HTTPS. If you take the default load balancer, for example, so you just tell the default load balancer that a network load balancer or software load balancer, which has layer 4 on it, you tell like, there's a URL, this is the endpoints, so these are the servers and port numbers you need to go to. And basically what it does, it basically routes the request, takes the request, routes the request, takes the request, routes the request, right? If the end server or endpoint URL is not working, it could be a timeout exception, or it could be a page not found, it could be like anything. So it basically responds to whatever is responded by the backend. But layer 7 is different. How? The layer 7 not just routes the request, but it basically analyzes the request. It's basically the difference between redirect and rewrite. So if you're aware of Apache HTTP server, this is something very, very much similar. A redirect basically redirects the request. You will have a source URL and destination, basically redirects. But rewrites the URL. So it just changes the whole concept of a URL and change it based on IDs, based on how your URL is written, what kind of interaction or what kind of a user input it requires. So same thing happens over here. So here, what I've done is 2 different ways of ingress over here with the same port number. So if you see the port numbers and the public IP is the same, there's no change there. The public IP, it's going to end up is the same. Okay. But the public IP address over here with the port number /console is different because the Ingress will understand it. I'm getting a request which says /console. Okay. So then it says like, oh, okay, I'm getting it /console. Then the person is trying to, browse the admin console. So I should go to this service, which is admin service. And then on another URL, I say that on another Ingress, configuration, I say that, okay, if you find this URL, the host name has this, then go to cluster service. So here I give the host name and I say like, okay, look for a host name which says like this. If it says like that, then go to my application, which is on the cluster service, and then your application will be served. If your URL has slash console, even the host name is the same, but it has slash console on it, then go to admin service. So that's how you kind of differentiate it, and that's what layer 7 does. Okay, not just this, but it can even complicated your Ingress service to have much more complicated way of handling the incoming request. So in my Ingress file, I have written the same thing. I think Oracle has written the same thing. It's not me. So to here you have the prefix path over here, which is slash console. So when a URL comes in and says slash console, then basically go to the service name, which is prod daily domain admin service, which is running on 7001 port number. So this is basically an Ingress route. It basically routes the request by looking at the incoming request. And then you have another file over here, so which is this guy. So this guy will look for the host name. It matches the host name. It matches the host name. If it matches the host name, then it's going to go over to the service, to this particular service name, prod daily domain cluster 1, to the 8000 port number where this particular service is hosted on. Now, why we specify port numbers is because a service could have multiple port numbers. That's the reason why we specify port numbers. Just like how your service of traffic had 2 different port numbers, right? Likewise, a service could have multiple port numbers, like this one, for example. So that's why we specify the port number, or else there's no need for it to have a port number there. All right, fine then. So I think I don't have anything else to discuss with you guys about this topic. Only thing which is pending right now is to implement this and see how we get to work with the console as well as your application. All right, so we'll do it on the next video. I hope that you understand. If you have any questions, please leave it on the question section. I'll see you on the next one.